Alright guys, I'm going to see if I can make a decent video about ball bearing turbochargers and why we don't build them or sell them, why I have a hard time recommending them for a diesel application. Disclaimer, when a ball bearing turbocharger is working right and you have it set up right, there is no arguing that a ball bearing turbocharger, size for size, to a journal bearing turbocharger will outperform it. It just will. It will spool faster. It can handle more RPMs. It's just it can make more power. The problem that we have run into is I can't make the things live in a diesel, especially when you try to use these vehicles on the street. Any type of towing, driving to work, stuff like that. And I'm not here to say that they can't work. I know there's lots of people out there that do. We get bombed with ball bearing questions. It's just a really common question right now, and it has been for about the last year. And we've honestly tried to make this work. This is some of the attempts to make this work. But I can't, in good faith, offer this, even though it could make more power, it could be faster on the drag strip, sell you something that costs more, that makes it 50 miles. And hopefully with this video, I can explain why I believe we've seen those failures. And this is not a blanket statement. I don't know what other guys are doing and how they may or may not make it work and how they feel about this, but this is how we feel about the ball bearing stuff and why we see these types of failures. So across the board, with not only what we have played with, this is an S300 that hangs in the shop ceiling. If you guys ever been here, this is the one hanging from the wall. These are S300 and S400. These are 10 mil Garrett carriers that we've used in hybrid S300 and S400 small frame chargers. And this is a 16 mil Garrett carrier that we used in our S400 prototype ball bearing. What we were trying to do was integrate Garrett carriers with S400s because we have so much infrastructure in the Borg-Warner world for wheels and covers and turbine wheels, so that we could integrate that and not have to spend, $5,500 on a GT55 type of a deal. What we see with these failures, though, they're always the same. Always the same. I don't care what manufacturer turbocharger it is. When we see a failed ball bearing turbocharger, they are always the same. And what we have found is that you have a thrusting issue. So the turbocharger, the assembly will start moving in and out. So you're thrusting. But you don't really there is no thrust assembly in a ball bearing unit like there is in a journal bearing unit. This is the stack up on a journal bearing, and this is the thrust bearing. It's captured in the bearing housing. So there's actually a thrust component that takes the forces pushing this way and the forces pushing this way. On a ball bearing turbocharger, you don't have that. You capture the outer race. So this is like a wheel bearing in an old pickup truck or something. You have an outer race and an inner race, and then the inside, they can spin independently of each other. You capture the outer portion of the race. So imagine a bearing housing being here. You capture this so it can no longer go back and forth. So that more or less is your thrust capture, your component there. When we tighten the compressor wheel onto the shaft, on an S400, the torque spec is 25 foot-pounds. On a Garrett of very similar size, that torque spec is 7 foot-pounds. So what we're doing there is, why is the question, do you have to have so much less torque on that compressor nut? That compressor nut is holding this wheel down. That friction, that torque holds that. That is finger tight. We go from spinning to finger tight and is locked on. That's 25 foot-pounds. Why on the same size platform do we need less torque? And over many months and lots of broken turbos and lots of time under the hoods on our trucks figuring this out, what we found out was these two, the inner races, they are separate from each other. And when you tighten them down too far, imagine the wheel bearing that your daddy was teaching you how to tighten the front of your pickup truck however many years ago. You tighten that thing down till it doesn't spin, and you back it up a quarter turn, put your castle nut on it, and you send it down the road. You take all the clearance out of it, and you back it up. What we have going on is you torque these less, okay? So you do not take that load, you do not overload the bearing races. So you're not wearing the ceramic ball bearings out. And that's fine, and it'll work real good, and it'll make a little bit of boost, and you can run it fine. But what we all know in the diesel world is we're not out here making 20 pounds of boost to make 1,000 horsepower. This little dude right here is probably going to get spun up to 60, 70, 80 pounds of boost. Why? Because diesels by nature, when we make power, are abusive. So now you take something that's torqued less, so it has less surface area holding the compressor wheel on, okay? And this is the same even if this is an integrated nut, it's not tightened down as hard, so it's easier to knock loose. And when we surge it, as we're shifting gears, you get off the throttle and you get the that is boost coming backwards through the intake track. So if you have 40 pounds of boost, you shift into fifth gear and you drop down to 30 pounds of boost, you have 10 pounds of boost that your engine cannot digest. So that air then goes backwards through the turbo. And when it tries to go backwards through the turbo, these are reverse thread. See, this is barely, I'm spinning this the wrong way. When you spin it backwards, it's gonna cough. And look, that cough right there, look, now I can't turn it. I cannot turn that. So by nature, when we surge any turbo, when we surge it, it is tightening itself. And when we continue to tighten it, torque spec is 7 foot-pounds. When we tighten it and tighten it and tighten it, what we're doing is making that wheel bearing tighter and tighter and tighter. That is going to knock out the thrust components. It's not even really a thrust component. It's just wearing the cage down and the ceramic BBs or bearings in there, and you get movement. And I know you're not going to be able to see this on this phone video, but you can feel that movement. You can pick up this turbocharger right here, and you can hear it and feel it click. And you'll end up making contact on your compressor wheel, and every one of these guys that run a ball bearing turbo, when they fail, sounds like an angry vacuum cleaner. It was working great, it was crazy, I went around the corner and it sounds like a vacuum cleaner, and now my compressor wheel's touched. It's the exact same story. They're not failing in different ways. They all fail identical across the board, whether it is a Garrett carrier, whether it is a 100% OEM Garrett unit, whether it is an aftermarket unit, it doesn't matter. These bearings are failing the same type of way, and then we're making contact and the turbo goes to hell. And these are really expensive, and these are going to hell in literally a lap around the block. I put this turbocharger right here, was on Barney, the race truck. I made it about 6 miles in 2 launches, and it was awesome. It was amazing. It spooled an S480 like an HX35. It was crazy. Get back to the shop to take a look at what you got going on, see if everything's good, and it was trashed. There's another reason that this part is worn, but it had still failed in the same way. I could have probably got another lap around the block out of that thing. Couple passes down the track. It's just something that, as badly as I want it to work, because man, they are sweet when you get them lined out. These work better in gasoline applications or in applications where the truck has very minimal miles put on it. Your great big horsepower guys that literally idle get pushed to the line, make a 5-second pass, and get pushed back to the pits. Those trucks get 10 minutes of runtime put on them in a season, where you can put 10 minutes of runtime on your truck going to the gas station. And you're driving your truck through all the gears, maybe towing a trailer, and you see that surge much more evident in a daily driver type situation. Even though it might not be as extreme, you see that surge through all the gears back and forth all day long as you're driving it, slowly tightening that nut, until we knock out these bearings. Whereas on a journal bearing setup, this here is what they ride on, and there is a limitation to how fast you can spin this. These bearings ride on a film of oil. That is how this turbocharger spins. These ride on a film of oil, and you can spin these a journal bearing turbo too fast, and you push the film of oil off of the inside of the bearing to the steel shaft and the bearing to the cast iron, and you go metal on metal, and then the turbocharger fails. And you'll see very similar things happen at that point in time. The contact on the compressor or the turbine, your thrust can go low on oil as everything starts to jam in and do bad things metal on metal. A ball bearing turbo can be spun faster because you don't need oil to lubricate the bearings. The oil is more of a cooling effect. That is the main difference between these, and why this one can make more power for the same size. It simply spins easier, and you can spin it harder because you don't require the film of oil to keep it lubricated. But that is really, in a nutshell, how we feel about ball bearing turbochargers. I want them to work, and if your ball bearing turbocharger works, more power to you. They are cool when you get them to work. They spool crazy if you've never experienced it. An apples to apple, a 67.7 to a 67.7-ish on the same truck, like, it's different and it's awesome. But if it's only awesome for 15 minutes before it's a financial problem, that's not what we're after. Whether it's a daily driver or a race truck or whatever, like, we don't want them blowing up every other pass. You want them to have some type of a service life, even if we're doing something extreme with them. It shouldn't be a one and done type of deal. But that's how I feel like we're beating these up in the diesel world. We're not making 20 pounds of boost out of them. We don't have a 7,000 RPM working load you would see on a higher horsepower gas. We're literally making our power on most pickup trucks are making their power from like 1,800 to 2,600 RPMs. That's it. You can get out into the racing world and you make your power maybe from 26 to 46. Maybe you've got a 2,000 RPM window of power, but I doubt it. You're probably more in that 800 RPM working range of making your peak torque and horsepower on these diesels. And we're asking it to make 60, 65, 70 pounds of boost just immediately. And then we get off the throttle or bang a gear and surge and tighten that whole assembly down. So that's my spiel on ball bearing turbos, why I don't sell them. I'd love to build them, sell them, but I have not found a configuration or an application in the diesel world that I'm comfortable saying that it's right for you. Unless you get out into the great big horsepower stuff where we talked about earlier, where the vehicles are filled deck plate engines, whatever, and they have no runtime. Their specific purpose in life is to go from A to B. You can get more of a service life out of it simply because it's not running as long and you're using a much bigger setup like this, lower boost. They can live. But this stuff on street trucks I found it to be very frustrating, and hopefully that makes a little bit of sense to you guys. This has taken a long time to figure out. Lots of phone calls, lots of busted parts. This is only a handful of the stuff we've piddled with. It's frustrating. I want these things to work. I hope you guys get your setups figured out where you can run stuff like this, but This example right here is why we don't build or sell ball bearing turbochargers at this time.